Good morning, dear Form 3 student. Welcome to the class again. We are still on the topic optics, and today we are moving forward to look at how lenses form images. We are equally going to look at images formed by convex lens, images formed by concave lenses. Before we move ahead, I quite remember we have covered a lot on this topic. We started with the reflection and refraction. We equally did total internal reflection. And then last week we did application of total internal reflection. Today we are going to look how images is formed by lenses. I remember we learn of types of lenses. We learn of convex lens and concave lens. Lenses form both real and virtual images depending on the type of lens and the position of the object in front of the lens. The image of a point is formed where all rays from the point converge or appear to converge after passing through the lens. Converge means the meeting point of rays, where rays are meeting or where rays are going to meet. That is where an image is formed. In order to locate the position and size of an image, any two of the following three rays are sufficient. Okay, let's have the first ray. How we can locate the position and size of an image. Here we have a ray parallel to the principal axis, which passes through or appear to pass through the principal focus after refraction through the lens. I repeat again, a ray parallel to the principal axis, which passes through or appear to pass through the principal focus after refraction through the lens. You have the diagram here. We have the diagram there. From that diagram, you can see how the ray is being refracted. We take the second point to locate the position and the size of an image. A ray passing through the center of the lens, which leaves the lens undeviated. The ray passing through the center of the lens, which leaves the lens undeviated. It means there's a ray that passes through, it doesn't deviate. You can see on the ray diagram on the board where the ray passes through the lens undeviated. Take the third case where a ray passing through the principal focus, which emerges parallel to the principal axis after refraction through the lens. You can see on the diagram, you can see on your screen, there is a ray diagram. Any of the three can be used to draw the image or to locate the size and the position of an image. Any of the three cases above can be used to locate the position and the size of an image. Okay, let's look at image formed by convex lens. Remember, we have image formed by convex lens, and we equally have the image formed by concave lens. Okay, we start with convex lens. A convex lens can form both real and virtual images. Remember that a real image is an image that can be formed on the screen, while a virtual image is an image that cannot be formed on a screen. And here we are saying that a convex lens can form both real and virtual images. The characteristics of the image depends on the position of the object in front of the lens. When we talk of the characteristics, we are talking about the size of the image, the position of the image. We talk about the distance from the center. We equally talk of the height of the image. The diagram below shows the nature of the images formed with the object at different positions in front of the lens. Okay, the different position, we are going to look at the different position. The image formed beyond 2f, when an object is placed beyond 2f, what would be the nature of the image? When an object is placed between 2f and f, what would be the nature of the image? When an object is placed at f, what would be the nature of the image? And when an object is placed between the center and f, what would be the nature of the image? Here we're going to look at object placed beyond 2f. When an object is placed beyond 2f, the image form is, okay, these are the characteristics of the image form when an object is placed beyond 2f. The image is real. The image is between f and 2f. The image is inverted or upside down. The image is smaller than the object or diminished. The image is on the opposite side of the lens. This is applicable in camera lens, in camera photocopying machine. That is how a camera functions and a photocopying machine. It means that objects in the camera are placed beyond 2f. And when objects are placed beyond 2f, the image is real. The image is inverted and upside down, inverted or upside down. The image is on the opposite side of the lens. It is applicable in camera lens, and also in photocopying machine. Okay, let's look at object is placed at 2f. What happens when you place your object at 2f? When an object is placed at 2f, the image form is real, inverted or upside down. The image is the same size as the object. The image is at 2f. The image is on the opposite side of the lens. And the application of this is found in photocopying machine. Application you can also see in photocopying machine. Move further, we look at object placed between f and 2f. Remember f, we have done f. F is the focal length. An object placed between f and the 2f. The image formed here is real. The image is inverted or upside down. The image is beyond 2f. The image is magnified or larger than the object. And the image is on the opposite side of the lens. The special characteristics here is the image is magnified or the image is larger than the object. This is applicable in projector and compound microscope. It's applicable in projector and compound microscope. That is how the device is designed. Okay, here we look at image placed at f. What happens if you place the image at f? When an image is placed at f, when an object is placed at f, the image formed is at infinity. That is applicable in searchlight. When I say the image form is at infinity, means that we cannot locate the position of the image. The image is from some distance away. We can only imagine, but we cannot determine the position of the image. That's why I said the image is formed The image form is at infinity. Infinity is a point where we don't know. And this is applicable in searchlight. Searchlight. That's where we can apply this. Okay, we look at image place. When you place an object between F and the center of the lens, how is the image going to look like? When you place your object between F and the center of the lens, how is the image going to look like? Here the image form is virtual. Remember, virtual means that the image cannot be formed on the screen. Therefore, the image form here is virtual. The image is erect. The image is on the same side of the lens. The image is magnified or larger than the object. There's another special property. The image is magnified. The image is erect. Erect means that as you are standing, that's how the image is. The image is magnified. The image is virtual. These are the special properties of the image formed when an object is placed between F and the center of the lens. And we can apply this in magnified glass or simple microscope. We can also apply this one to correct long-sightedness. We can also apply this to correct long-sightedness. When we talk of long-sightedness, is when a person can see a far can see a far object but cannot see a near object. We call that long-sightedness. Where an object, somebody can see a far object but cannot see a nearby object. That is a long-sighted person. Okay, let's look at object placed at infinity. When you place your object at infinity, how is the image going to look like? Here the image produced is real. The image is inverted or upside down. The image is on the focal plane. The image diminished, or the image is smaller than the object. The image is on the opposite side of the lens. The image is on the opposite side of the lens. This is equally applicable in camera. This is equally applicable in camera. We have the human eye. Our eye is applicable. Okay, let's look at image formed by concave lens. We are done with convex lens. Let's move ahead to see image formed by concave lenses. Okay, image formed by concave lenses, they have general characteristics. And these characteristics are the image form. We have the image is virtual. The image is upright or erect. The image is smaller than the object or diminished. The image is always on the same side of the lens. This is applicable in eye lens to correct short-sightedness, door peephole. This way you can apply it to correct short-sightedness and also in door peepholes. These are the general characteristics of image formed by a concave lens. Dear students, we have illustration of image formation, and the video you are going to watch below will give you a better understanding of image formed by concave and convex lenses. You watch the video and draw the diagram of each case explained above. Thank you very much, dear students. We have come to the end of our lesson. We shall meet again in our next class. Stay blessed.